I love video games. Ever since I first played Mario Kart on the Nintendo GameCube, my love for video games has only grown. I grew up playing games like SimCity, Big Time Madness, Call of Duty, Ghost Recon, Battle for Middle Earth, all the way to Fallout 3, Skyrim. Some of my most fondest memories is playing Halo on the split screen, or creating my own maps with time splitters and facing off against all the bots. I've always wanted to create my own video game, but I never had the time to sit down and learn how to do it. Once I graduated and started working full time, I realized that it was now or never to actually sit down and learn how to use the Unreal Engine, how to use blueprints, learning the basics. It was this year I would finally start. I spent about 3 months watching Udemy tutorials, YouTube videos, messing around with settings in the Unreal Engine. Nothing much came of it, although I started to get familiar with the software and the user interface. And the thing was, what kind of game would I even make? What would it even be about? And would it be any good? At the time I started, I was a big fan of Space Engineers, and Oxygen not included. I liked these games for their technical aspect. They were challenging, but simple enough where any player who was a fan of crafting, building, or simulation games can learn and have a good time. A friend of mine suggested, hey, why don't you make a game similar to using Legos? Game where you can build using the blocks. It won't actually be Lego, but you can do everything that Lego has. And the good thing about this idea was I would not have to do any 3D modeling. All I would need to do is remove the trademark from the studs on the 3D model files. I would then be able to edit them and add materials to them to make them my own unique building blocks. I love Legos and grew up playing with them, and this was such a great idea. So with that, I was going to build a space exploration building survival game. I spent about 3 months creating a Milanote document as my game design doc. I mapped out the mechanics, physics, animation, and other elements that I might need for my game. Of course, I don't know how difficult this will all be to implement. I wanted to balance realism with simplicity to be able to code it, but also to not overwhelm the player with unnecessary difficulties and challenges. So I wanted to make sure I had a simple but good experience. I wanted it to be realistic, but not too realistic to the point where only simulation players were interested. I wanted to make it interesting for everyone. Some of the concepts I wanted to include for the solar system were actually orbiting planets, gravitational forces, and basic orbit principles. To test the mechanics, I used basic shapes as planets. In the future, I would like to use voxel planets from Voxel Plugin 2.0, but they do not yet support large world coordinates. Hopefully, they will soon. The current scale I have set is about 1/1000th the size of our solar system, although I might shrink this in the future. I began doing a lot of research on distances and how long it takes for certain orbits of planets to rotate around the sun. I used this as a baseline to determine how far each planet should be from each other to be similar to our solar system. I also wanted the solar system to be modular, so I focused on using the construction script. I wanted to be able to, in the future, randomize all the aspects of the solar system so every time you play, it is a brand new experience. The planets will be in different positions, the sun might be a different size, certain planets might have more moons than the other. Starting with the sun, I wanted to make the sun change color depending on how hot the surface temperature was going to be. So I started creating a function that would change the color of the sun depending on the temperature that was selected. I started messing around with the curve tool and realized it's very similar to an XY graph. On the x-axis, I have the temperature values, and on the y-axis, I have my RGB values, which together will create the color that I want. I was very excited about taking on this challenge to be able to build a basic but functioning solar system. A lot of the functions I used in this were simple mathematical equations, so once I understood the formula for the math, I simply replicated that in blueprints. This was a great way for me to not rely on tutorials but be able to problem solve and figure out how to get it to work simply by trial and error. It took a while, but it was also a great learning process. I spent a great deal of time researching planets, their properties, orbit mechanics, and temperature mechanics to understand how I could implement it in a game, how it could be simplified so that the player can have the function of dealing with temperature, orbits, without actually making the game very difficult to program or very computational heavy. Without going into a physics lesson, the speed at which a planet orbits the sun decreases logarithmically the further it is from the center of the sun. This is an inverse square relationship, so planets that are further out move exponentially slower than planets close to the sun. I want to emulate this mechanic in my game so I do not have to program it manually each time. The hard part was actually getting the planet to circle around the sun. I did not know how to go about doing this in a way that was most efficient, so I had to do a little research. I know there were ways to attach a component to a spring and have that spring be a certain radius and have it circle the sun as an attachment. But I didn't want to do this because I wanted to make it more modular so I can edit the orbit path, tilts, and size. I did some digging and found out something called a Bézier curve. The Bézier curve is named after French engineer Pierre Bézier. This curve is used in computer graphics and is defined by a set of discrete control points that defines a smooth and continuous curve by means of a formula. They are used in computer graphics to approximate real-world shapes that would normally be too difficult to calculate. Because I am doing my coding in blueprints, I decided to do some more research to try to find a solution that wasn't in C++. I was able to find a diagram along with some comments on a forum which explained how to implement it perfectly. I decided to create an actor class component of a spline, which I can then use to attach to other actors. This spline will be the orbit path. I can have multiple moons circling a single planet, and based on size parameters, if there are multiple orbits, I can create minimum and maximum distances between them so there is no collision between the moons if there are multiple moons. I wanted to create semi-realistic orbits, so I created a variable that allows me to tilt the orbit up to about 5 degrees, which, based on our actual solar system, our orbits are not perfectly flat, perpendicular with the sun. They do have some tilt to them. I was very happy to get the end result working. Here you can see a moon orbiting around a planet, with another planet orbiting around the sun. The next step would be to get these to work simultaneously together. Once I had the basic orbit mechanics working, I spent some time figuring out how I can get realistically timed orbits similar to our solar system. For example, how can I create a planet that circles the sun at a rate proportional to the scale of the solar system, similar to how long it would take our Earth to circle the sun, which would be 365 days. I did this by scaling everything down so that it was consistent with each other, and based on the distance determined how long it would take for the planet to circle the sun. Once I found a speed that was comparable to Earth at that scale, I then scaled everything back to how it would be in the game. The end result is a planet that orbits the sun at a rate proportional to its realistic real-life counterpart at a certain distance away from the sun. Of course, I cannot make the orbit speeds so slow that one in-game year is one real-life year. So I did some calculations, and based on how fast the Earth moves around our sun, which is 365 days, I did some calculations based on the scale of the sun, the distance from the sun, and the size of the solar system. This planet is moving at an accurate speed. This was important to figure out, so now I have a baseline of what an actual in-game Earth year would be. I added some orbits to the planets themselves, so now I can attach moons. Because I created the spline as an actor, I can attach it to almost any planet. It also follows the same rule as the further from the planet, the slower the orbit. This here is an example of two moons orbiting a planet while simultaneously orbiting the sun. Even though these are basic shapes and it's just a proof of concept, I was very happy I was able to get this to work exactly how I wanted it to. The next step was to design the build menu. The build menu is the most important part of the game, as it is where the player can select the bricks that they want and the material that they want to build whatever it is that they need to. This was far more difficult than I could have ever imagined, but as I went through it, I started getting a better understanding of how variables work. The biggest takeaway I got from this is coding is simply a transfer of data at every single step of the way. Of course, I did get help from ChatGPT in providing me some steps on what is the most efficient process and the best way to go about doing something. I wanted the menu to be modular, so I would have to do the least amount of work possible when populating all of the building blocks. I designed this function to be able to take all of the information from data tables and automatically sort through it based on the category it is assigned and the name of the block. The build menu will then become populated with the new data. When I got this to work, I was so happy because this was one of the most difficult things I've had to do, but I learned a lot from it. I spent weeks trying to get just this menu to work, but that's weeks I won't have to spend learning how to do it again. I hope you liked this devlog. I will be posting my progress monthly. Please like and subscribe to support the channel. Thank you.